Hey everybody, my name is Joshua Ernie, and I'm an integrated science and technology major at James Madison University. I'm making this short video series to help ISAT 310 students and others understand the basics of the engineering equation solver, or EES, and how you can manipulate the software to accomplish what you need, specifically in the field of thermodynamics. Now this first video is an introduction to EES, so if you already know what EES is and what it can do for you, it might be in the best interest of your time to skip this video and move on to the next. So the first thing you'll probably ask yourself is, what is EES? EES is a piece of software that was developed by William Beckman and Sanford Klein, who are both professors at the University of Wisconsin-Madison who teach thermodynamics and heat transfer to undergrads. If you wish to see more information on these professors, a link to their profiles are in the description. Now, the second thing that you may ask yourself is, what can EES do for me? Fundamentally, EES does algebra and calculus in the fields of thermodynamics, heat transfer, and fluid mechanics. On a more thermodynamic-specific level, you can find solutions given to thermodynamic properties of a substance, do parametric studies, generate PV, TS, and other plots, and also do dimensional analysis for you. Now for the persons who are a bit more explorative, EES can do integration, derivation, and therefore EES can do optimization also. Now let's go ahead and look into booting up EES. Alright, so if you've never used EES software before, the first thing that you're going to want to do is download and install this software on your computer. Your instructor will give you guys a link, and from there you can go to a website where you will be able to download EES. If you're using a Macintosh computer, unfortunately EES will not run on a Mac, so you can get around this in multiple different ways. The most simple being to just find a computer with Windows on it and use that. The second would be to run Parallels on your desktop, and the third would be to partition your hard drive and run Windows off of Boot Camp. Alright, so let's get into EES. This is the icon for EES. Just go ahead and double click that to boot up the program, and you will be greeted with this box. It gives you some information about EES. Just go ahead and hit continue to get out of that. Here comes another one, equations window. It's got some basic information on EES also, and some frequently asked questions in blue. Let's go ahead and X out of that. So this is what we're going to be working with here. So let's go ahead and hit File, New, and that's going to open up a new equations window. In the bottom of the equations window are some parameters that you can manipulate. Just by clicking them, you can change what's going on down here. The most important one, and the one you might be using the most, is this one right here. So we're going to go ahead and click on that. Now what this does is allow you to edit your preferences for what kind of units that you're going to be using. You can switch between SI and English. When you're in SI, you can switch between Kelvin and Celsius, so on and so forth. So once you get those set up to your preferences, I'm just going to leave them the way they are right now. Just hit OK, and we'll move on from there. So the next thing that we're going to be doing is working with operators. Alright, so the first thing I want to teach you guys is how you can do some basic mathematical operations using EES. So let's go ahead and boot up EES. I'm gonna click continue, X out of the first equations window, then go to File, New, to create a new window for you to use. Now the first thing I want to do is break this window into sections that describe what is going on. So in order to do that, we're going to use comments, and you can do comments in EES by either using quotation marks like so, or you can do curly brackets like this. Okay, and comments are just something that gets ignored by EES when it is running through your program solving for your variables. So let's do a simple addition problem. A for addition is equal to 1 plus 1. Nothing surprising there. The plus sign is used for addition. Let's use S for subtraction. Is equal to, actually let's just use B. B is equal to 2 minus 1. Use the hyphen for subtraction. Let's make another comment here for multiplication. And here we're going to do 2 multiplied by 2, and you can see that you use the asterisk to multiply in ease. Division. Let's do d is equal to 4 divided by 2. You use the forward slash for division in ease. And lastly, exponentiation. Whoops, I'm sorry. I did those as regular parentheses. Make sure you're using square brackets and not parentheses. Okay, and for exponentiation, let's just set e is equal to 2. You're going to use the caret sign for exponentiation, raising something to the 3rd power. Alright, so first thing you can do is to solve these is check your equations first using the check mark there. There are 5 equations and 5 variables. No syntax errors were detected. It's exactly what we want. So go ahead and click OK. Go over to the calculator that's right next to it. It says solve, and click that. It's going to go ahead and solve our equations for us. Now, here we have 1 plus 1 is equal to 2. 2 minus 1, b is equal to 1. 2 times 2, c is equal to 4. 4 divided by 2, d is equal to 2. And 2 raised to 3, e is equal to 8. Alright, I want to show you guys, there are 2 different ways that you can do exponentiation in ease. And I also want to show you guys a way that make your variable names more attractive and easier to read. So let's just do e underscore 2 is equal to 2 raised to the 4th power. Let's go ahead and check it again. 6 equations, 6 variables, perfect. And go ahead and solve. So here you can see that for the underscore 2, e's actually made it a subscript, which is what it's going to look like in your textbook and places like that. It makes it look more official, which is very nice. And here we have it equal to 16. One more thing I want to show you guys before we close out this video is that e's can actually interpret the writing out of Greek letters like rho, subwater, to actually be the Greek letter rho, which looks like the P, which is commonly used for a density of a substance. Also, you can use square brackets at the end of your numbers to notate that they're units. So here I'm using kilograms over meters cubed. Let's go ahead and solve this and see what we're getting out of it. So here you can see that it changed the rho that I spelt out here into the Greek letter rho. It gave me a subscript of water, had the density of water equal to 1,000 kilograms per meter cubed. Alright guys, that's all I have for you today. Thank you for watching, and make sure you check out the next video.